power series is essentially a polynomial with infinite degree. This is the form that they have. Notice the difference in the power series versus the series we've done before is this has an x in it. So what we get here is a polynomial. The domain for this is considered to be the set of x values for which it converges. And to find the domain, usually what we have to do is use the ratio test. Let's look at an example here. This is a power series, just x to the n, with n going from 0 to infinity. If we wanted to figure out the domain here, this one, we could actually find it without using the ratio test because it's a very simple series. If you notice, it turns out to be geometric, and its common ratio is x. Therefore, it's going to converge whenever x, absolute value, is strictly less than 1. So that means its domain is everything from -1 to 1. This is also called the interval of convergence. Let's look at another example. Suppose we have this series, x to the n over n. N goes from 1 to infinity. I'm starting at 1 instead of 0 because we don't want to divide by 0 here. All right, so if you look at this, the first term would be 1 x to the first power over 1. Then you get x squared over 2, x cubed over 3, like this. Now let's use the ratio test on this. So we'll take the limit as n goes to infinity of a sub n plus 1 is going to be x to the n plus 1 over n plus 1. Then we have to multiply by the reciprocal of a sub n. So now we'll put x to the n plus 1 over x to the n, then n over n plus 1. Now this x to the n plus 1, let's rewrite that as x to the n times x. Now we can cancel these guys. This is going to go to 1, and so our limit here is x. So this will converge whenever x, absolute value, is less than 1. So that tells us that it converges when x is between -1 and 1. So our interval of convergence is it has the numbers from -1 to 1, but we don't know about the endpoints yet. Do we include those or not? We have to check them individually. So we have to check to see if the endpoints are included. So we'll do those individually. First, I'll plug x equals -1 in. That gives me this series, -1 to the n over n. Okay, that's the alternating harmonic series. That converges. So therefore, we include this point. If we plug in x equals 1, again, I'm plugging that in up here for x. Don't get confused and plug it in for n. Plug it in for x. So we get 1 to the n. I'm not even going to write the n because it doesn't matter. Over n. This is the harmonic series which diverges. So we exclude 1. So that means our interval of convergence is everything from -1 to 1, including 1, including -1, but not including 1.